Absolute value recording. Woo! Video for you, absolute value inequalities on Canvas. Thanks for being here and watching, or at least checking your answers, or hopefully watching and learning. So, two different things going on. Absolute value, which splits off into two different equations, as well as inequalities, which also has you double check those two equations to make sure that we get it right. So first of all, don't forget that the absolute value, it keeps things positive. So for example, the absolute value of 5 is 5. And the absolute value of negative 5 is also positive 5. Nice. So that's important to know and remember. The other thing important to remember is that, well, we'll just go ahead and do it. Number 1. So number 1 says the absolute value of v minus 5 is greater than 7. Ooh, that's a greater. Greater. Let's actually start with number 2, which is a what? A less than. So it's a less than, but I like to call it a less than. And the reason why than is than, a less than. You try it. You say it. Less than. So less than, it's just less than, but I'm going to throw the D on there. And the reason why is because of the word and. And what does the word and mean? And means that you're going to be, and it says equal to, less than, or equal to. And so equal to means a closed dot and all the solutions in between. So that's a less than. So let's go ahead and review a little bit here. So less than is going to be less than and greater than, or greater. So those are both going to be open dots, first of all. And then if it's less than equal to, greater than equal to, those will be closed dots. So that's the first thing we also want to talk about there when we're graphing these inequalities. And beautiful, beautiful, looking at our solutions, which I think we'll come to later on in the assignment. But I'm probably going to still do it on these ones because you want to really get good at that. Okay, beautiful, beautiful. Celine, let's just dive right in there. So this is a less than. And so what that means is that we're going to go ahead and split this off. Absolute value means split it off into two different equations. And then drop the absolute value. So we're going to have negative 5x is less than 5, which is the original equation. And less than, we're going to write negative 5x. But this time we're going to go ahead and switch the inequality. Because absolute value, remember, so absolute value, we're going to set it equal to a negative 5. Remember when we did solving absolute value, we did two equations. The first was exactly identical. The second, you went ahead and switched the sign from positive 5 to a negative 5. But when you do that, you also got to switch the inequality sign to make sure that the solution actually works. Cool. Well, number 2 is like everything because now we're going to solve for x now. But there's another trick you got to do too. Watch my other video for a better explanation. I think it's number 12 towards the end of that video of my other video from last year's assignment. Where we're using Mr. Lucarini's this year since he set it up on Canvas for us. So basically we're going to divide by negative 5, divide by negative 5. And so when we do that, we want to go ahead and switch the inequality sign. So instead of less than now, it becomes greater than or equal to. And then 5 divided by negative 5 is a negative 1. Now again, why did we switch the inequality sign? Well, you don't usually do that, but it's when you divide by a negative, right? When you divide by a negative. So whenever you divide by a negative, then you're going to go ahead and switch, switch the inequality sign less than to greater than. And you'll see if we didn't switch it, right? If we didn't switch it, here's the frowny face. It'd be greater than equal to negative 1. We'll discuss that in a second. Now we're going to do the same thing over here. Divide by negative 5, divide by negative 5. We're going to switch the inequality sign. So that becomes x is greater than or equal to, but then we're going to switch it, so less than or equal to. Negative divided by negative is a positive. 5 divided by 5 is 1. Okay, so if we didn't switch the inequality sign, it would be x is still greater than, if we didn't switch it, sorry. So if we didn't switch it, then it'd be less than -1, and then over here it would be greater than or equal to +1. Cool. Okay, so then let's just look at that for a moment. We're looking at 1 and -1, so this number line won't be huge. So we're going to go from here to here, and we got 0, and we got 1, we got 2, and we got -1, -2. So basically, we're going to do the correct solution and then show, so we're going to do the correct one. So all numbers x greater than or equal to -1, so greater than or equal to -1, so equal to means we do a fill in the dot. And then less than or equal to 1 would be fill in the dot. And so since, let's use a different color there. Let's go and do red. So we're filling it in because of the equal sign. Filling it in because of the equal sign. Good, good, good. Now it says less than or equal to -1. So less than would be this direction. And then greater than, that's greater than -1. So greater would be like 0, 1, 2, 3. It goes in this direction. And so we want all the solutions in between from -1 to 1. Right? From -1 to 1. So this could have been written as a inequality compound, right? We could have went ahead and said x is less than 1, which is true because that's the statement right there. But then we could have taken this one and it says all numbers x is greater than -1, so -1 but greater than -1. Oops. Greater. Showing you so much in one problem. Man, this was a doozy. That's why I didn't do this last year. I used a different worksheet that wasn't so crazy the first problem we do. And you're learning a lot. Okay, so again, all numbers x is greater than or equal to -1. All numbers x is greater than or equal to -1, but less than 1. So that's the inequality answer we're looking for on your homework, I believe. So we'll double check that. I mean, this technically is the true answer, but I think when we go to Canvas, I think it'll look like this, and now I'm having deja vu. I dreamt this. This is crazy. Okay, Buda wondered why I was making another video in my dreams. I already had one made. Okay, so again, if we chose the wrong answer and we did not switch those inequality signs, then we would say all numbers less than -1. And so we'll go ahead and do, let me see here. We'll go ahead and do yellow. Ooh, not good. So less than -1 would be this way. And then greater than equal to 1. Ooh, that's wrong because that would be this way. And so if you tried to plug, like say, for example, 2 back into the problem. So if we plug 2 back into the problem, here we go. That didn't work. Okay, so if we plug 2 back into the problem, that'd be a -10. And the absolute value of -10 is a +10. And is 10 less than or equal to 5? 10's not less than 5. No! So 2 is not a right answer, and neither is 3, and neither is 4, and neither is 5. If we plug -1, 0, or 1 in there, it should work, right? It should work. So if we plug 0 in there, for example, that would be 0 times -5 is 0, and 0 is less than 5. Good, good, good. So then, let's see here. If we plug a 1 in there or a -1 in there, for example, a 1 in there would make it -5, and the absolute value of -5 is a +5, and 5 is less than or equal to 5. So the 1 does work. The 1 does work there. 1 works. If you plug a negative in there, negative is a +5, and the absolute value of +5 is +5, which again is less than or equal to 5. So then our -1 and our +1 both work, and everything in between, because 0 works too, because we plugged it in. So this is definitely our answer. We'll double check on Canvas for you there, just to double check for number 1. Beautiful. So we'll double check over here. Solving. Let's just save it. All the changes I had made. Save. There we go. Let's go back and edit that sucker and just take a look at the question there, which was number 1. No, it was number 2. We were looking at this one. Okay, so then there's our problem that we were working on. Good, and there's our correct answer. Do you see it? Yep, there it is. So our correct answer is between -1 and 1. Notice it's a compound because it was a less than, right? It was a less than or equal to. So that's going to be a compound, so it could have been that one or this one. But we got the answer -1. Now, the other thing we're going to learn is if you see a word or in there, that would be a greater, or. So we'll look at that one next right now. And so that'll be, for example, looking at doing this really intently for our online learners because they weren't in class to learn all this. So again, if you're in class and already know what you're doing, you can just fast forward this video. Don't even fast forward and check your answers. Okay, so number 1 now we see. Excellent. So number 1 deserves violet or yellow. What the? I don't know what's going on here. Okay, so now number 1, you can see that this sign right here says this direction. So that's a greater. Okay, so it's a greater, alligator. It's a greater symbol. It's going to eat you. Omp, omp, omp. So that's a greater. And so that means you're going to end up with 2 different solutions, and it cannot be compounded together because they're going to go in opposite directions. Okay, they're going to go in opposite directions. And so in this case, because there's I don't see an equal to. Do you see an equal to? I don't see an equal to. No equal to. So what that means then for no equal to is that we're going to do an open hole and an open hole when we go to graph these suckers. So this is especially important when you get down for the graphing purposes right here. So like number 11 all the way to number 20. So that's why I'm graphing at the same time to help you on these ones. Beautiful. Okay, so this one's actually pretty set up, pretty fast and easy. Here we go. So again, it's inequality as well as absolute value. So we're going to do the original v minus 5 is greater than 7. And then we have v minus 5 is, remember, change the inequality sign, less than, and then -7. And this will just ensure that we get all the solutions that make this inequality, this absolute value inequality, true. Okay, so now we're going to go ahead and add 5 to the other side. Add 5 to the other side. Man, that weed whacking is loud out there. Okay, so we're going to add 5 to the other side. So we have v is greater than 12. Okay, because we just added 5 to the other side. Notice this time we did not switch, right? Because why? We didn't divide by a negative. We just added 5, that's it. So this time we did not switch the inequality sign, and that's because we did not divide by a negative. Cool. Okay, so we have v is greater than 12. Beautiful. Then we'll add 5 to this side, add 5 to this side. So now we have v is less than. We did not switch the sign because we did not divide by negative. -7 plus 5 is -2. So now we have or, okay? So we're going to have or because they're going in opposite directions, right? If you look at the number line on this sucker. So we'll have maybe like, I don't know, -3, -2 is important, 0, all the way down to 12, 13. Okay. So now you notice again that because it's there's not an equal to, we're going to do an open hole. So we'll do an open hole at 12, which is right here, and an open hole at -2, good. Now let's read it. This is all, remember, this is all numbers greater than 12 and not equal to, so not include 12. So that would be 13, 14, 15, and so forth. So we're going to go in this direction. And so all numbers greater than 12, like 13, 14, 15, 16, 17, or all numbers less than -2, less than -2. There we go. So all numbers, yes, I am making this video for you on my lunch break. You're welcome. It's because I love you. So thanks for watching it with me. Okay, so all numbers less than -2 is like -2, -3, -4, -5, and so forth, right? going in that direction. Beautiful. Okay, let's test it. So -5, for example. So if we put a -5 in there, -5 minus 5 is a -10. And -10 absolute value becomes a +10, which is indeed greater than 7. So that works. If we plug a 0 in, right, because that's not in the solution set, so it shouldn't work. No, should not work. So if we go ahead and plug that in there, so let's say, for example, 0. 0 minus 5 is a -5. The absolute value of -5 is a +5 is not greater than, so not greater than 7, no, 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 and that's why 0 does not work. Then if you plug in 13 or 14, that will work. So again, here's our solution. Ready? V is greater than 12, but less than -2. So less than 2, greater than 12. So if we go back there and just take a look at this problem that we just worked on together, there it is. And there it is. V is greater than 12 or V is less than -2. Beautiful. Okay, we'll do one last one on here to finish off this video because we really did a good job. This is more of a lesson / video, right? Wow. Ooh, 16 minutes. Definitely should probably end this sucker. Okay, so we'll jump down here. And I think I want to do 17. 17 looked pretty. 17 looked pretty. 15 looked pretty as well, didn't it? Nice. So 15, for example, maybe we'll do 15. Well, let's look at, I really like 17 for some reason because there's a division in there. Ooh, and it's a great tour. Okay, so let's do 15 first because it's a and. So again, we'll do 4n minus 3 is less than or equal to 3, and then switch the inequalities, switch two things. Right, you got to switch two things going on here. Let's stick with blue now. That is not working. I said blue, mate. Okay, so then we're going to go ahead and do 4n minus 3 is less than, good. So is, got to switch it now, greater than equal to a -3, right? Because we switch the inequality symbol and we switch the sign of the number at the end. Beautiful. Now our two equations are set up. We drop the absolute value. So we're going to go ahead and add 3 to both sides. So we get 6. And then we have 4n is less than or equal to 6. Then we'll divide by 4, and you should probably reduce that. N is less than or equal to 6/4, which reduces to actually be what, 3/2? Yeah, 3/2. So there's one of our solutions, hopefully. Plug it back in. Should work. Okay, then again, we do it again. But this time when we add 3 to the other side, we actually get greater than or equal to 0. And then we divide by 4. We did not divide by a negative, so we don't have to switch the inequality. It just stays the same. Stays the same because we didn't divide by a negative. So then we get 0 divided by 4 is just 0. N is greater than or equal to 0. Nice. Now, because, again, what is this symbol right here? So the symbol is a less than. That means everything in between. So we're going to go all numbers greater than 0, and less than 3/2, which is the same as 1.5. Okay? So now we look at our options, and this is between 0 and 10, so that can't be it. This is a gray tour problem going in opposite directions. So is that one. So, this one's 0 and 1.5, and all numbers in between. We found it. It's D. So number 15, the answer is D. So we do have all numbers between 0 and 3/2. And notice this one had a less than here, but not here. Yeah, that's interesting. Okay, so the answer to 15 is D. Then we'll jump to number 17. Now it's number 17. So we do have multiplication going on, and you want to isolate that absolute value first. So you do want to go ahead and divide, right? You want to divide. So we'll have to edit it at this point and start all over. Stupid! Okay, so we're going to start all over with this sucker. Okay, hi, welcome. This is number 17. I made some mistakes, and so I fixed my mistakes for this video, starting now. So again, we want to divide by, right? Divide by a negative 7 first. So we're going to go ahead and divide. Here we go. So divide by a negative 7. And then don't forget, when you divide by a negative 7, you want to switch the inequality sign, which I forgot to do on that last video there. So we divide the negative 7 first, get everything to the other side. And so then when we do that, we actually get less than or equal to negative 10. Okay? And then at this point, I'm going to still go for it. But I think at this point, we'd probably say no solution. Probably. And the reason why is, can you have a number less than negative 10 that's absolute value, which makes it positive? Can you have a positive number? Think about it. Can you have because absolute value makes it positive, can you have a positive number that's less than negative 10? No. So that's probably just no solution, but we're still going to do it. So we're going to go ahead and break it off into two equations. The original is 2x minus 6, which is less than or equal to negative 10. And then the other one is 2x minus 6 is greater than or equal to positive 10, right? Okay, so now we're going to go ahead and add 6 to both sides. So then we get, what, a negative 4. Nice. Divide by 2. Divide by 2. We did not divide by negative now, so we're good. So x has to be less than or equal to negative 2. X has to be less than or equal to negative 2. Good. Then we add 6 on this sucker. And when we add 6 on this guy, we actually get 16. And we get 2x divided by 2 divided by 2. So then we get x is greater than or equal to 8. So good. Now it's doing the gray Tor thing, which I messed up last time. So now we're looking at all the solutions, right? We're looking at all the solutions that are greater than or equal to 8. So that would be 9 and onwards. And it says an equal to. So that means we can go ahead and fill it in and go that direction. And then we have 0, and then we have what, negative 2, negative 3. And so now this is saying to go ahead and fill it in negative 2, and all numbers less than negative 2, that direction. Because why? Because this is a gray, remember, this is a gray Tor. A gray Tor problem goes in opposite directions. But the problem is, when you plug these in, so for example, if we plug in a negative 2, go back to the original, plug in a negative 2 in there. Negative 2 times 2 is a negative 4, and negative 4 minus 6 is a negative 10. The absolute value of negative 10 is a positive 10, but then you have to times it with that negative 7, and you get a negative 70, which is not greater than or equal to 70. And if you do the same thing, plug a 9 in, or plug an 8 in, or a 9, you'll get a negative number that's not greater than or equal to 70. So 17 is no solution. No solution for number 17. So go ahead and put that on there. Awesome. Thanks for watching. Keep on busting through these absolute value inequalities. You're the best. Thanks for watching. Peace out. Thanks for watching. Bye-bye. Bye. 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 Turn me off. Come on. This video is long. Bye. Thanks.